Hi guys, in this video we're going to have a look at volume of spheres. So a sphere is basically just a 3D circle, so think of like a football or something like that. And the formula to work out the volume of a sphere is 4 over 3 times by pi times by the radius cubed. Okay, so we're going to have a little look at working out the volume of some spheres when we're given the radius or the diameter and half a sphere here called hemispheres. And then we're going to have a look at going backwards to work out the radius if you've been given the volume, work out the diameter if you've been given a volume, and then we're going to have a look at a little shaded problem at the very end. So if you want to skip forward, that's fine. If you want to be doing some of these with me, you'll need a calculator because some of these get a bit tasty. So let's get cracking. First one here then, we have the radius is 6. So all I'm going to do is substitute the radius of 6 into this formula, like so. So we've got 4 over 3 times by pi times by the radius, which is 6 cubed. So get your calculator, use your fraction button. So 4 over 3 times by pi times by 6 to the power of 3, and it gives it to you in terms of pi. In this case it's 288 pi. So if the question in the exam says leave in terms of pi, that's what you do, and the units are centimeters cubed because it's volume. However, you might need to put it as a decimal, so just press the old SD button there. So we have 904, and I'm going to round it to one decimal place, so that second decimal place being a 7, we'll round that up to 0.8 centimeters cubed. Okay, so that is the first one. No dramas there. Let's have a look at this one then. So this time we've been given the diameter, but the formula uses the radius. So the first thing you're going to do is half that to get 5.5 centimeters, which is the radius, and then that's what we're going to use. Now, if you don't have a fraction button, don't worry, because I'm going to show you how to do that in a minute anyway. So 4 over 3 times by pi times by the radius, which we just worked out was 5.5 cubed. Now, if you don't have the fraction button, you just have a normal calculator, don't worry. For do the 4 over 3, just do 4 divided by 3 and press equals. Obviously mine has the fraction function, so it'll come out as a fraction, but what you'll probably see is 1.3 recurring. That's exactly fine, not a problem. So now we just need to times that by pi, by 5.5 cubed, and we get this answer in terms of pi, which isn't very nice. So I'm just going to press the SD button there to get the decimal version, which is 696.9 to 1 decimal place centimeters cubed. Okay, right. Hemispheres, and so half a sphere. Exactly the same thing, work out the whole sphere, and at the very end we half it, because that's all we want, we only want half of it. So again, I've been given the diameter here, so the first thing I'm going to do is work out the radius by halving it, which is 8 centimeters. Okay, substitute that into our formula, 4 over 3 times pi times by the radius, which is 8 cubed. Told you we'll be using our calculator quite a bit, so I'm going to use the fraction button again. So 4/3 times pi times by 8 cubed, and leave that on your calculator, but just jot it down. So 2144.66. Okay, because we want half of that. That's the whole sphere. Okay, so we now need to divide that by 2 or times it by a half, whatever you prefer. And the reason why I say leave this on here is because when you divide this by 2, it gets you a much more accurate answer. Okay, so divide by 2, again press the SD button, which is 1072.3 to 1 decimal place. Okay, so make sure you do divide that by 2. So many people I see work out the whole sphere, think grid's in, done, happy days, and then they forget to half it. So just make sure you do half it. Exactly the same thing with this one. Okay, I'm just going to substitute it straight into the formula, 4/3 times pi times by 4.5 cubed. That's going to tell me the whole, oops, wrong button. That's going to tell me the whole volume for the sphere. 4.5 cubed, yep. So again, Don't get that off your calculator, leave that, just make a quick note of what that comes out at, which is 381.7. We need to half that, which I'll now do, divide by 2 or times by a half, whatever you prefer, which is 190.9 to 1 decimal place. Of course, if the exam wants it in a particular way, you can round it however the exam wants it, or leave it in terms of pi like we did there. So there's the basics. Let's have a look at when we go backwards and we need to work out the radius or the diameter. So let me just grab my other sheet. There we go. Right, so in this particular case, I've been told what the volume is. It's in terms of pi, doesn't matter. And we need to work out the radius, okay? So the first thing we're going to do is we're going to substitute in everything that we know into our formula. Well, the 4/3 stays the same. We're still going to times it by pi. I need to times it by the radius, cube, sorry, I'm being silly there. And then we get the volume, which is 972 pi. Okay, so I've substituted everything that I know. The only difference is I haven't got the radius, I've got the volume. And all we're going to do is use the flowchart. So I start off with R, and the first thing I do is I cube it. So on my calculator here, it's the X to the little box. So what I'm going to do is just use the X and then put like a 3 there to illustrate the cube, or you can put C, U, B, or E, or however you want to do it. But first thing we do is we cube it. Okay, done that. Then I times it by pi. And then I times it by 4/3. Now, because I'm timesing by pi and I'm timesing by 4/3, the order of those actually doesn't matter. You definitely need to cube it first, but the timesing of these, because they're both timeses, doesn't actually matter the order. And then we have 972 pi. Okay, now typical flowchart, let's go backwards. So 972 pi, and when we go backwards we do the opposite. So instead of timesing, I now divide by 4/3. I now divide by pi, and the opposite of cubing a number is the cube root. Okay, so let's get the calculator ready and see what comes out. So 972 pi, do this step by step. So 972 pi, divide that by 4/3 equals, divide that by pi equals, and then we need to cube root it. So if you keep your answer here, if you then put the cube root function in and press the answer, it will use your previous answer, and then you press equals and it comes out the radius at 9. Of course, if you have cleared it, it's not a problem. Just press the cube root function in your calculator and type the number in. It's absolutely fine to speed things up. Okie dokie, that was that one. Let's have a look at this one then. So exactly the same thing, but this time I need to work out the diameter. Not a problem. We do exactly the same thing we did here to work out the radius, and then we just double it because we want the diameter. Okay, so let's do that then. Substitute in what we know. Well, we know we've got 4/3 times pi times by the radius cubed, and that equals the volume, which is here. So 47,916 pi, big number. Okay, flowchart it just like we did before. So I have my radius. Again, I'm just going to use that little x to the power of 3 because that's what it is on my calculator, but that's just the cubing. Again, it doesn't matter the order. In this order, I did times by pi times by 4/3, just to show you it works either way. Because they're both timeses, I'll do it the other way around this time. So times 4/3 times by pi, and then we have our volume. And we go backwards. And we do the opposite, so I now divide by pi. I divide by 4/3. And the opposite of cubing is cube rooting. So I need to cube root the answer. And then I get back to the radius. So let's do this step by step again. There's my 47,916 pi, lovely. Divide that by pi. Divide that by 4/3. Happy days. Cube root it again. Keep your answer there, or write it down and do it the other way around, but I'm going to keep my answer there, and then I'm going to do the cube root function and press the answer to use my previous answer, and I have 33. Now, just reread the question. It says work out the diameter. If you have the radius, okay, you must double it to get the diameter. So be careful, make sure you don't do all that hard work and then get it wrong at the very end. So double 33 leaves us with a diameter of 66 centimeters. Okay, so just make sure you do reread the question and just make sure you have actually answered it. Okay, this one here, if you have a hemisphere or half a sphere, how do you work out the radius? Again, we're just going to use that same formula. However, the volume we've been given isn't for a whole sphere, it's only for half. So the first thing I'm going to do is double this. Okay, so if you double 2,250 pi, so times it by 2, you have 4,500 pi, and then that will be the volume of the whole sphere, which we can now then use our formula for, and it's exactly the same process. So 4 over 3 times by pi times by the radius cubed equals this volume of the whole sphere, which is 4,500 pi. Then we can do a quick flow chart. So R, again, the little cube there, times by 4 over 3, times by pi, again, the order doesn't matter of those two. And then we have our volume. We go backwards by doing the opposite, divide by pi, divide by 4 over 3, cube rooting, and we get back to R. So what do we have? We have 4,500 pi, step by step, divide by pi, divide by the 4 over 3, and again, keep your answer there, and shift cube root your answer, and we have the radius to be 15. Okay, so you may think, oh God, how do I do that? Really simple, double the volume, and it's exactly the same thing as we did here. And the last thing you can be asked to do is very common types of questions with area, and also it can be used with volume as well, where you have to work out the shaded part of a shape. And just realised I've missed the E off volume there. Okay, so how do we do that? Exactly the same thing if you were doing the area or anything like that. You work out the whole volume, you work out the volume that's missing, and then you take the 2 away. So that's what I'm going to do. I'm going to do a very quick sketch of a cube just to tell the examiner that's what I'm going to work out. And it's a cube, so all the sides are 8. So the volume of that will be 8 times 8 times 8. I think it's 512, but I will just double check. Yes, it is, yeah. 512 centimeters cubed. There we go. Now we need to work out the volume of the sphere. So again, little diagram just to show that's what I'm working out. So we have 4 over 3 times by pi times by the radius. Be careful, 8 is the diameter. So the radius is actually 4 centimeters. So 4 over 3 times pi times 4 cubed. Let's see what that comes out with. 4 cubed. And that comes out with 268. I'm going to round it to 1 decimal place, so 0.1 centimeters cubed. And then all we do is we take the total away from what's missing. So 512 minus 268.1, 268.1, and we are left with 243.9 centimeters cubed. Okay, so it's that simple. If in the exam they have a cuboid and they've got, like, say 2 or 3 or even 4 spheres inside, don't panic. Just work out the volume of the cuboid, okay, the whole thing, and then work out what one sphere is, then times it by 2 if there's 2, times it by 3 if there's 3, times it by 4 if there's 4, and so on. And then just do exactly the same thing. Do the total volume, take away whatever is missing, and then you'll have your final answer. Okay guys, that's everything for spheres. Hopefully that's useful and helps with whatever revision or exams you've got coming up. Thanks for watching.